Hey, everybody, this is Larry. It's day 29, I think, of the Leetcode day. Trying to the like button, to subscribe button, drop me in Discord, let me know what to think about today's bomb. I am at the Denver airport, so we're gonna keep it short and sweet, hopefully. And yeah, I had a good hike today. I'll probably post some of the missed intros, in the future. Today I am on a red eye, so it's a mess. Anyway, yeah, let's take a look at today's bomb and then we'll get back into it. Today we have 2411, smallest subway with maximum bitwise or. Is this related to yesterday's problem? I guess. Okay. Size of the minimum size non-empty non something. That's the maximum bitwise or. There has to be a sub array. That's one. And yeah, the maximum possible bitwise or starting at any index is 3. And so the shortest sub array that use it 0, 1, 2. Okay, so I guess you have to get the maximum possible bitwise OR, which, as we said yesterday, is just the bitwise OR of every number, right? And then now, starting at so it has to be I going forward. In this case, it is 1, 0, and 2. I guess the first thing I want to look at is okay. So it's not like an n square algorithm. You have to actually do a little bit better than that. Hmm. Well, yeah, let's start by saying or sum or whatever you want to call it is just you go to the XOR of all the numbers. Oops. And that would be your max bitwise OR. And then now you have to do it for each thing, right? It's interesting. I'm trying to think whether there's a property that that we can reuse. There is some sort of a structure, I suppose. Well, one is just sliding window, right? Maybe? Is that true? Can you do sliding window? Because basically for the first one, you have a length. And the second one, now you remove one. Even with or, it's a little bit awkward to do. You remove one, then in theory, either they're already or you have to keep going, right? Like there's no way for it to shrink after removing a number. So I think sliding window kind of makes sense, but you have to kind of keep track of it. And just sliding window is very annoying to remove because the way that you want to write a sliding window is something like this, right? So left is 0, 0 for right and range of n, right? Where my keyboard is acting really weird. So something like this, right? And then now you want to add right or nums of right more specifically to the window. In this case, it's a little bit different because I think you actually want it the other way, maybe, but that's basically the structure, right? Because in this case, then now, maybe the structure is something that is actually okay. Maybe I just kind of got lazy on this one, but like, something like this, and then while I don't know, something like bitwise sum or bitwise or sum is not equal to or sum, then we extend to the right? Something like nums extend into the right, and this is actually yeah, we move left -1, I suppose, right? Something like this. This is kind of the structure I'm thinking of for a sliding window. The problem is that extending to the right is easy. It's just adding next or, right? Oh, sorry, adding an or, but removing it is tough, right? Because that means that you have to recalculate for all the numbers, unless you keep track of how many bits there are for each binary digit. So I guess that's what you would do. It's kind of annoying, but I think that's fine. Yeah, okay, fine. Right? So maybe you do something like okay, so if left minus one b, then now we remove them. Yeah, maybe we just write remove for now. But otherwise, then now maybe we have the current or sum is equal to 0. Then now, well, this is not true. And also we said right is equal to 0, maybe? Oops. Well, that's not 0, but so you extend to the right and then you, yeah. So then now this part is easy conceptually, right? So someone like this, but then now we want to remove, right? So now to keep track of, and also at this point, then now you get the length, which is ends of data pen, right minus left plus 1 or something like that. That should be good for the most part. Yeah, I'm so tired. I hiked like 10 for like 10 hours. So I am cooked. But yeah, then now we have to just keep track of every bit, right? So maybe we have like a how big do the numbers go up to? 10 to the 9, so just 30 variables, right? So maybe like counts is equal to like 0 times 30. This should be fine, right? So then now we'll skip remove again, but when adding, what we want is for phi in range of 30, and maybe we should do p for the digits. Um, then if num sub right has a 1 in that digit, that's what this is saying, then what's it called? Then count sub I increment, right? And then now maybe instead of writing this, which maybe we still can anyway, we write something like current or, or sum is 0 to 0. And then now every time this is true, then now if count sub I is greater than 0, current or sum, it's like 1 over I, right? That's basically the idea. And then now for removing, it's the same idea, right? So now that we remove it, then we do for I in range of t, if num sub left minus 1 and 1, right? So if this is greater than, if this is the 1, then we want to remove it, right? And then, yeah, maybe we just kind of just do the same thing here. And then, yeah, if count sub I is greater than 0, then we again current or sum we do 1, right? And then now, of course, this is now current or sum. Maybe that's a better name. I don't know what it is it? Maybe give it a quick spin for a sec. Num sub right. I guess num sub right can go out of bounds. So what happens if num sub right can go out of bounds? Is it -1? The length of the minimum. I mean, it shouldn't happen here anyway, so I guess maybe I'm wrong, but that still does not understand. It still does not explain to me how it can be. Like, there should be an impossible case, even though this is just wrong, right? Yeah. I mean, this seems like I'm just off by 1. Why is that? It's probably because we want left to be inclusive and right not to be, but because it's exclusive on right because yeah, right doesn't count the number, but okay, fine. Okay, let's give a quick submit. Hopefully I didn't make a silly mistake. Ooh, I did make a silly mistake. No, I'm not gonna lie. I'm at the airport and I've been up. I didn't sleep yesterday because I had to wake up at 3 a.m. for the hike, so I'm right and I'm ready to go. But yeah, it's okay. So the max, what is the max thing? Probably just like 7, right? So 7, Yeah, that's the part that I don't get. Like, what do they want the answer to be? Like, that's why I was saying that. Am I misunderstand what they mean by? Is it maximum for the entire thing or just maximum for? It still doesn't really describe it because okay, so I am just confused maybe. Or some. So I imagine this is seven, right? Like I said, this is seven, but three and two will never be seven, or three or two is never going to be seven. So why is it that we expect one and not two? I think this problem is just like worded really poorly, maybe. Even six three has two, but then the three has one. I mean, am I misunderstanding this part? Is it like the maximum? What is the minimum? Okay, maybe I misunderstand minimum size of 900 something starting with I. Minimum size 927. Oh, it is only from I to J, not the entire thing. I think this problem is just kind of, but this example kind of confused us. Um, okay, so that is now a different problem. I don't know what I want to do. I think what we can do is binary search uh, at the very least, right? Because you just gotta keep extending and then, yeah, you can probably do a binary search, but I am not understanding this problem at all. Okay, what else can we do? I think part of me is just kind of stuck from where we had previously. Uh, well, I'm trying to understand this form. So, okay, so it's saying that, okay, so it's the max of the suffix, right? Maybe we can calculate that just backwards, right? Okay. It's okay. I think I'm just confusing this form, but we can for sure, okay, S is equal to, I don't know. Sorry, it's very loud in the background. I was hoping I could get this out very quickly, but maybe it's not happening. But yeah, okay. So it's just like a suffix best or something, right? You go to best of I plus one or num sub I, right? Something like that. And maybe you do something like this, and then best of I minus one. If you go to num sub I minus one, something like this, right? We can check it real quick. Um, and for this, we all confusingly they're all the same number. Oh, was it not? Maybe they were not. Maybe I just misunderstood this problem. Or example two. Yeah, okay, fair enough. But yeah, but this one should be three and this is seven, right? Okay. So then now we have to figure out how to get the max from that, right? Um, hmm, how would we get that? Well, two is going to be one, okay, because it just has one number. The three, it's saying, okay, you don't need the two because three is already max. And by definition, that means that the suffix, we don't need the two because the other stuff is the superset of that number, right? So then it is, I guess it's a similar logic, um, even though it is very confusing. If we go forward or backwards, I guess backwards, right? So like this, and then you go, still sliding windows. So I is, what is I? Maybe I could, is it the left or the right? No, it's the right, right? But then, no, we want this to be the left, and then the right is you go to N, and then now we want to say, can we remove num sub right and still have the same best of I, right? Or best of left. Maybe something like that. So then while right is greater than left. No, I guess it has to be greater than because that's one number. And and the same thing that we did before with the 30 digits, right? Maybe I should have put it away so quickly. But because then now the current or sum is equal to, well, by definition, it would be equal to best of I or best of left, right? But we have to do the thing with the count, right? So we'll have to do this again, I suppose. I am not a smart boy today, right? So then now we want to add num sub left. And wait, didn't we write this? So maybe we just take it. Well, this is the add. Okay, fine. We'll just copy it. Right? So basically, it's the same thing, maybe in different orders. And then now this is the current awesome. Right? And then basically, we want to see can we still have the same, which is the current awesome, right? So what that is saying is if everything overlaps perfectly, meaning that everyone has at least two occurrences, right? So then maybe we have someone like so that means that if there's a digit and counts up I is greater than, well, let's just put this greater than 0. So with the 1, if this is true, then this is good. Otherwise, then if this is equal to 1, that means that it is unique. So cannot remove, right? So then that means that it's going to be just to say good is equal to false, right? And then now, if good, then we can remove. So then we just subtract 1. And then at the end, it's the same thing. We just maybe off by 1. It seems like I've been kind of lazy about it. Yeah, let's see. Maybe I have an infinite loop. Maybe I have an infinite loop. Can remove. Else we break because we can remove anything. Okay. Right. Okay. That's not quite right. Mm, let's see. Yeah, four, that's okay. I mean, maybe that's just off by one. But that doesn't seem quite right anyway. Three, the suffix is three, and you remove the three. The answer is no, right? So then it's going to be three minus four. Four minus three plus one is two. So why is this not outputting two? Oh, I'm doing this backwards. So it should, it's not, I mean, it's still not right, is what I mean. But at least these two are right. So, okay. Now the two, can you remove the four? The three. And the answer is yes. Can you remove the one? The answer is no. Oh, we remove, but we don't actually remove. That's the reason why. And now we actually do remove. Okay, there we go. Maybe I'm just being bad today. I'm so underslept or whatever and tired. Let's see. Okay. Is that a good? Okay, yes. Yeah. Uh, that was disappointingly long. But yeah. That's why I have for this one. What is the complexity? I mean, this is standard sliding window, so this is going to be linear time. But maybe linear times d, right? So n times d. And that's it. I know that there's a while loop, but each of these it gets amortized to only get checked once. So yeah, n times d, and that's it. That's why I have for this one. Let me know what you think. Thanks for watching. Man, I can't even keep my eyes open. I'll see y'all later. Take care. Bye bye.